We'll now continue with part 2 of our examination of the Java object-oriented BardWords case study. In this part of the lesson, we'll show how other methods in the BardWord case study are implemented using object-oriented Java features. We'll also explain how the Java BreakIterator class can be applied to the case study. We'll begin with an overview of the Java BreakIterator class. This class provides methods for finding the locations of boundaries within text strings. 4 kinds of text boundaries can be analyzed using a BreakIterator, including characters, words, sentences, and potential line breaks. To demonstrate the use of BreakIterator, we'll apply it to famous bard verses from the play Hamlet, A Tragedy of Denmark, which are shown in the upper right portion of the slide. We'll start with the character text boundary. BreakIterator allows users to interact with characters as they'd expect to. For example, when moving the cursor through a text string to identify vowels, shown by the vowels highlighted in red in the example on the top right of the slide. BreakIterator also enables word boundary analysis, which is commonly used by search and replace functions, as well as text editing applications that allow users to select words with a double click. You can see some examples of words identified using BreakIterator in the Hamlet quote above. BreakIterator also allows selecting sentences with the correct interpretation of periods within numbers and abbreviations, as well as trailing punctuation marks, such as quotation marks and parentheses. Once again, the Hamlet example above demonstrates how BreakIterator could be used to identify the sentence starting with, "This above all to thine own self be true," and ending with, "Thou canst not then be false to any man." And finally, BreakIterator can be used to identify line boundaries, which can occur after the termination of a sequence of whitespace characters, such as a space, a tab, a new line, and so on. As shown by the red rectangles above, line breaks could occur any place between the different words we see here, including the end of line. To support these analyses, BreakIterator provides various factor methods, one for each type of text boundary. In particular, there's a getCharacter instance, getWord instance, getSentence instance, and getLine instance factor method defined in the BreakIterator class. The character examples method in that demo shows how a BreakIterator can be created to recognize characters in a string. Note how the getCharacter instance method is passed a locale, which is an essential part of BreakIterator since it identifies the customs and conventions of a user's native country, region, or culture. In this case, the locale parameter is indicating the Saudi Arabian form of Arabic. The character examples method creates a string containing Unicode characters that represent the Arabic word for house. This string and the BreakIterator created earlier in this method are then passed to the line positions method, which prints the Arabic word for house using the format shown at the bottom of the slide. Now that we've given an overview of the Java BreakIterator class, let's walk through more of the structure and functionality of the BardWords class and see how it applies BreakIterator. In part 1 of this lesson, we walked through the methods in the BardWords class that structure the overall flow of control through the program, including the main method and the process BardWorks method. The BardWorks class also defines methods that search the complete works of Shakespeare for given words and phrases. So now we're going to take a look at the find match and show regex matches methods. The find match method determines whether the work of Shakespeare passed as a parameter contains the given search word in its text, where search word, of course, is also passed as a parameter. This method begins by creating a BreakIterator that breaks the work into words, using the UK locale, of course, since we're dealing with the Bard of Avon, who's English. Find match next makes the work the text to search by associating it with the BreakIterator that we just created. At this point, the find match method uses a Java for loop to iterate through all the text in the work. The for loop gets the first and second word boundaries from the BreakIterator and uses them to initialize the previous and current loop variables. The for loop will keep going until the BreakIterator is done, which occurs when the current loop variable equals the done constant in the BreakIterator class. After the loop body finishes executing, which we'll look at in a moment, the for loop updates the current boundary to the next word by calling the next method on the BreakIterator. Here's what the loop body looks like. We start by getting the word between the previous and current boundaries by calling the substring method on the work string, which returns that word. We next check to see if the word starts with a letter or digit and whether it contains the search word. If so, we return true and bail out of the method. Otherwise, we make the current boundary the previous boundary and keep looping. If there's no match after iterating through all the words in the work, the find match method returns false. We'll now walk through the implementation of the show regex matches method, which displays portions of Shakespeare's works that match the given regular expression pattern that's passed as a parameter. Note that the BardWorks matching word list parameter only contains works of Shakespeare that have search word in them. Show regex matches starts with a Java for each loop that iterates through each work containing a matching word. A nested Java for each loop is then used to create a regular expression matcher and iterate through each regular expression that matches in the work. This for each loop will process its loop body as long as there's a match. In other words, as long as find returns true. The body of this nested for each loop displays information about the regular expression matches that occur. And we'll show this in the next part of the lesson when we walk through the code from start to finish. So that's the end of the second part of our case study on the Java object-oriented BardWords program.